Hello friends! While working in the Plasticity program, I encountered a problem. All Boolean operations involving a large number of bodies take a very long time to complete. I became curious about how many CPU cores Plasticity uses, how many cores other programs like SolidWorks and Fusion use, and how quickly these operations are performed in those programs. To find out the difference in speed, I will create an object like this. I'll create a new scene, delete this cube, select the circle tool from the center, choose the center point and enlarge it. I'll press tab and set the size to 100 millimeters. Next, we'll extrude it, also by 100. I'll select our sketch, hide it with the H key, select this edge, and add a chamfer of -3 millimeters. I'm using specific dimensions so that the model turns out the same in all programs. Here as well, set it to 3. I'll switch to the rear view. I'll select the line tool, draw it from the central point, and set its length to 4 millimeters. Like this. Now I'll draw a square from the center. I'll hold Shift and click on the line, and 2 more will appear, 1 parallel and 1 perpendicular. I'll draw my square along this parallel line. So 3 on one side and 3 on the other as well, like this. Now move it. I'll press GF freestyle. I'll select this point and move it to the end of the line. Now I'll hide the line. I'll select all the points of our square and set the chamfers and roundings of all the vertices using Shift Command F. Let's round the vertices to 0.5. Just like that. Excellent! Now I'll carefully hide our body. I'll select the element, extrude it, and display the body. We extrude it to 50.7, very simply, just like that. Okay, and we'll add a fillet along the edge. I press Shift Alt and select the loop. I set the fillet to 0.2. Like this. And now we'll create a linear array. In this direction, set to 84. Quantity, 18. Okay. Now let's rotate our body and enable selection. Let's set the top view. On this plane, play from selection, we'll draw a circle from the center. Something like this. Now we'll cut it out. Let's hide our main body. And in these elements, we'll cut it out. V difference. Select the bodies that it will trim. Like this. Let's hide the circle. And now show the main body. And like this, we trimmed our elements with this circle so that we could merge them. Otherwise, if we hadn't trimmed them, Plasticity would have given us an error when merging the bodies. Now let's create a circular array. Click Radial Array, select the center point, and set 75 instances here. Alright, Let's wait a bit. There. Just like that. And now we can start merging the bodies. Select all our bodies, and when I press the Q key, the Boolean command will appear. Now I'll start the timer. QQ union. The countdown begins. I interrupted the Boolean operation in Plasticity because it was taking too long. For me, the operation ran for 11 hours, and it still didn't finish merging the bodies. In the video though, only 6 hours were captured before the screen recording stopped. There's also another method for merging bodies. This is when you select all your bodies piece by piece, as you can see in this example. Here, I first select one part of the bodies, merge it with your main body, and then select another part of the bodies. And we can see that merging the bodies in parts is much faster than merging all the bodies at once. But now, let's combine our bodies in SolidWorks. I'll switch to SolidWorks and create a new part. I'll click on the home icon, select new part, choose the front plane for the sketch, and draw a circle from the center. I'll set its diameter to 100 millimeters and extrude it by 100. Now I'll make a 3 millimeter chamfer on the bottom and a 3 millimeter rounding. Like this. Now I'll draw a sketch on the top plane. Now I'll carefully switch the side and draw a square right from the center. I'll set the distance from the bottom edge to a value of 4 units, ensuring that there is enough space below. After that, I'll adjust the layout so that it forms a grid with 3 rows and 3 columns, making it a 3x3 arrangement. Now I will indicate the verticality of these 2 points and round the corner of our square by 0.5 millimeters. Like this. Excellent. Now let's move on to features. Extruded boss. We'll change the direction and extrude it to 50.7 millimeters. We'll uncheck the merge result box. Click OK. We'll round this face by 0.3. Like this. Now let's make a linear pattern. I'll specify the direction as the front plane. Direction goes that way. I'll specify the body saw body, and the distance will be 5.1. 17 instances. Excellent. Okay. Now let's make a circular pattern. This will be our direction, and in bodies we'll specify our bodies, starting from this body to this one. Here they are selected, 75 elements. Okay. Let's wait. There we go. And now we'll combine all these elements with our object. I'll rotate it like this and switch to the combine command. When I select all our bodies with the selection box, the timer will start to measure how long the body merge command takes in SolidWorks. Then I'll quickly click OK, and we'll see how long it takes. I select our bodies, and time begins. And now you can see how much time it took to combine the bodies in SolidWorks. Now we move on to Fusion 360 and do the same thing. I've already opened Fusion. Now I'll go ahead and close this tab and then create a new sketch circle drawn from the center. Okay. We are going to set its size parameter, which controls how big it will appear, to a value of 100. This means we finish the sketch, making sure everything looks correct. And now, at this stage, we'll go ahead and extrude it by a total of 100 millimeters. Now let's go ahead and add a chamfer with a value of 3 units to the edges, and also apply a fillet of 3 units as well. This will help to smooth out the corners and give the model a more refined appearance. Now let's create a sketch on this plane. Go to Create, select rectangle here, center rectangle, draw a rectangle from the center right here. Okay. For clarity, please set the size to 3 by 3 squares, making sure each side has 3 units. Then from the bottom, count up 4 units to determine the starting point. Alright. Select the centers and set them to be vertical. Okay. Now let's round off these points. I'll remove these lines. And here set it to 0.5. Alright. Here as well, once again 0.5. Here too. And here. Now we'll pull it all out. Exit the sketch, hide our body, go to extrude, and extrude our profile by minus 50.7. Like this. It's extruded. Now let's show our second body. Let's go ahead and add a fillet right here, just like this. Set it to 0.3. Like that. Now go to Create, and here, select Pattern, then Rectangular Pattern. Select this instance, specify the axis. Please carefully set the distance to exactly 84 millimeters, and set the quantity to precisely 18 units. At axis 1, here it's 18. There. Okay. Now let's create a circular array. Pattern, circular pattern. And here, remove these instances. Let's disable this one. The axis is this one. And here, set 75 instances. Like this. Okay. There, we've created all our elements. Now we can proceed to combining. Let's go to Combiner, go to Target Body, and select our initial body. And here, when I select all the bodies with a frame, just like in SolidWorks, the calculation will begin and I will start timing. Selecting, the calculation has started. Now the bodies will be joined, and now you can see the time it took here. And here is the total time it took to perform the combine operation in all the programs we looked at today. For greater accuracy in measuring the time these commands took in SolidWorks, Plasticity and Fusion, I performed the same calculation but without screen recording. And here you can see the timing results I got without screen recording. As you can see, the results are very similar to those I obtained while recording the screen. My brother Robert also decided to take part in this video. He also recorded a short segment about the speed of the combine command in Rhinoceros 3D.
Now I want to show you the speed of the combine command in Rhinoceros. To do this, first we'll create a dummy object. Let's turn on grid snap and create a circle with a size of 100. There, right here. Enter, and extrude it by 100. There we go. We get a little cylinder like this. Now let's add some details, like fillets. Set to 3, enter, click, 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 and a chamfer. Chamfer also set to 3. Click, click. We have a dummy object with a chamfer. Next, add elements to it. Now let's create the elements. For this, we'll select a square from the center. There we go. We'll just draw a line. From here, right from here, 4 units up. Click. And at the end of this line, we'll create a square, 3 by 3 millimeters in size. 3, oops. 3, enter, 3. Let's turn on rounded to make it rounded. We'll set the rounded value to 0.5 for the 3. Just like that. Now we have a square. Let's place it in the center of our cylinder. With move, I think we'll set it to -50, which is half the length of our cylinder. That's it. Now it's in the center, as you can see. And now we'll do an extrude of 50.7 so that it sticks out by 0 C. Now it sticks out just as we want it. Let's turn on the mode to make it opaque, and here we'll set the rounding to 0.3. Fillet edge. Next, set the radius to 0.3. Enter. And let's select all of this. Click, 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 click. There, it's rounded. We can use cell PRV to make all the lines disappear. And now we're going to arrange our element. Click where there are a lot of cubes, hold it, and select linear array. How many elements? Let's set it to 18. Where does it start from? From the center of the square toy, right there. Just like that. Now we have 18 elements. And now we'll rotate them. 75. We'll make 75 such columns of these elements. For this we'll use circle array. Click on the center of our cylinder, right here, click, set it to 75 elements, and specify 360. There, take a look, enter. Our cylinder is now filled with these little squares. Let's open the perspective view. See that? Now let's select all these elements. And if I now click on these two spheres, Boolean union, the merging will begin. Starting in 3, 2, 1. That's it, the merging is in progress. Rigging is finished. And this was Alex and Robert FTF with you. Subscribe to the channel and give this video a like. Bye bye everyone!